Hello, today's presentation is about the Libra suite. This is the Line internal developed machine learning improvement toolkit. Thank you very much. So today's agenda is like this. First, introduction. So let me introduce myself. My name is Zhang. I'm in the data labs of Line, working for the machine learning planning team since 2019, and I am working as the product and project manager of machine learning. Thank you very much for the opportunity. So today, I would like to talk about the Libra, that is the internally developed toolkit of Line. And in a nutshell, machine learning's life cycle, as you see here, after the deploy of the model and the offline evaluation is done, and after offline evaluation is done, and move to online evaluation. And finally, after the result of the online evaluation and until the release, in those three stages, we will have the support, the development and operations. That's the toolkit to be used. At the moment, it is consisted of three components. Each roles and relations is shown in this architecture diagram. On the left and bottom, machine learning systems generated recommendations data. Based on that, Libra checker will automatically create the demonstration. For instance, Line manga, the recommending titles, cover, and description to the sample users that can be checked. And those informations or contents will be confirmed on the demonstration in a form of web page. And on a Libra checker, you can display, confirm, and share. Now move to the right. The online testing or A/B testing spec to be done on an online basis, that will be set on Libra. And A/B test requirement and across all the Line users will be divided into target groups. And then each group recommendation data is applied. So those set up input is coordinated with the service-side systems so that A/B test will be performed. Finally, the Libra reports role. During the A/B test implementation, impression or click and other type of log through Kafka, it will be consumed on a real-time basis, and the user information, demographic data located in Hadoop, that will be joined, and the data mud will be created depends on the KPI, and those data will be imported to the Elasticsearch and delivered to a front end through API, and metrics and dashboard will be automatically created. And why these tools was developed internally in Line? Because when we didn't have this kind of tools, we had some challenges. I want to talk about three challenges especially. First, whenever we launch A/B testing, we had to pay a lot of cost for communication in terms of communication with the service side, and the machine learning engineers on top, and test planning personnel or analysis or reporting type of data engineers efforts also was costly. And also the machine learning systems was deployed and A/B testing is held, and until the releases to the service side, the waiting time was very long. And on top of the communication costs, log collection, analysis, or service side sharing, it took a very long time. And finally, other than the quantitative analysis, the demonstration for the qualitative analysis, it was created on a scratch basis. Therefore, development effort took long, so there was no standard or common tool. Those were the challenges. To overcome these challenges and problems, the mission that Libra Suite have, there are three things. First, for the internal service of Line, limited cost, more A/B tests can be performed. And number two, development and deploy of the machine learning, analysis or reporting and release, those cycle can be accelerated. Finally, the machine learning solutions qualitative assessment, we need to have a demonstration tools common to internally. At the moment, who are involved in the Libra suite, I just want to introduce. As an operational development team, linedevday labs, 3 teams are involved. First, machine learning team, the core development is in charge, and data science team are the users and testers, and data visualize team is in charge of the UI UX development. So with the collaboration of those 3 teams, Libra Suite development is underway. So key development members, we have 5 members, 1 PM and 3 engineer plus 1 designer. Normally we do have other work to do, and 20 to 30% of the efforts and to be involved in the Libra Suite development. And for the key users, each service side user, service side of line and PM and engineer, as well as data labs, data scientists, and machine learning engineers. For the purpose of development and analytics for the machine learning, and PM, the service side A/B testing result or coordination. So those are the purposes and key users. Now, in the next session, I want to talk about the components of the Libra Suite. I just touched on earlier. At the moment, the Libra Suite is consisted of 3 components. After the release, in the order of the releases, Libra mainframe and the Libra report and the Libra checker. Now, Libra itself. So this is the contents management system to support A/B test setup. Based on the set rule base, the lines all users will be divided into test group, and those grouping and the other A/B test required set items will be fed or coordinated with the server-side system in the form of JSON. This is the Libra's actual screen capture. What you're seeing now is the list screen. Across each services of line, A/B test is shown and listed up. By service, the user group is divided, and each service personnel is assigned the admin and editor rights. So this is the detailed page. Related to A/B testing can be set up and recorded. And key settings, for instance, test period, test status, or test targeted user grouping rule, and also the size and the number of the groups, and all those option items to be coordinated with the service side. And on top of A/B testing, the logic of the machine learning will be gradually released to service side. That is a gradual rollout function that is also available. The result of A/B test, if the one logic is very good, but still sometimes worrisome to release to across all the users all of a sudden. Therefore, gradual rollout like 5%, 10%, and finally 100%. That is a function. Basically, the planning of A/B testing and setup can be done on the screen, and the communication with the service side can be done through this screen. So compared to the past, there is no discrepancy regarding the test requirement, and also the communication became smoother so that we can reduce the cost dramatically. So this Libra's utilization is now explained. As of September, 26 services within line were supported. Total of 462 A/B testing was completed. And so far, number of users accounts for 282 users. This is the result of a monthly A/B testing performance. And as you see, end of the year or early New Year, Japan and overseas, it's a long vacation period, so the utilization is a little low, but the rest of the month, constantly 30 or so A/B testing is performed. Next is a Libra report. Mainly, the status of the A/B testing is monitored on a real-time and batch form, and 2 patterns and log will be collected of the service side, and depends on the key metrics, and the data is exchanged, and dashboard will be automatically controlled and developed.
This is the actual screen capture. First, it's a list of supported services and the list of recorded A/B tests. The title of the A/B test, the implementation period, and the person in charge information are listed up. Basically, it inherits the service grouping of Libra itself, so the person in charge can access it with the same authority. Next is the generated A/B test monitoring dashboard screen. In addition to count of events such as impressions and clicks, indicators such as whether there's a statistical significance from the lift are also calculated automatically. You can also filter by demographic information such as the user's device OS and region of the location. This screen itself is implemented in SPA format. So if you share the URL with parameters with the service side personnel and analysis side data scientists, everyone can check and share the test progress in almost real time. Compared to the past, it is now possible to detect abnormalities during the test, determine the release at the end of the test, and coordinate the next action more quickly. As for the current usage status of Libra reports, it's been about half a year since it was released, so the number of services it supports is 8, which is still less than that of Libra itself. 78 A/B tests were recorded in 6 months. Log delay is 10 minutes at minimum, meaning the log of events such as an impression or click to be collected by the system via Kafka and reflected in dashboard metrics. And finally, I would like to talk about Libra Checker. It focuses on supporting machine learning qualitative evaluation and will be a system that collects demo data from demonstration setup, machine learning output data, converts them, and automatically generates a demonstration web page. This is a screen capture of Libra Checker. I'm showing you an example of a sticker recommendation demonstration. The left column shows a sample of the current version of the recommendation data, and the right is a sample of the newly developed recommendation data to be compared. Each can show up to 100 items. This is a screen capture with a grid layout that is much easier to see. As you can see, in addition to the sticker image, you can see the product link to the Line sticker shop, the author information, and sales-related numbers that are partially hidden due to a grown-up situation. In the case of an in-house tester, the data recommended for that tester can be confirmed by specifying the user ID. And in the case of general users, a dummy ID is assigned from the viewpoint of personal information protection and can be displayed randomly for confirmation. The screen layout does not change for each service, but the contents and appearance of the demonstration data will change according to the target service. For example, in the case of a sticker, things like sticker image, author information, price are displayed. But in case of Line News, the title of the news, catch copy image, and posting date and time are displayed. Since it is a brand new service that its version 1.0 was just released at the end of September, the number of services we currently support is only 5. As for the specification, the maximum number of comparison groups for qualitative evaluation is 11, meaning 1 group for the current logic plus the maximum 10 groups for comparison. And 1 group can display up to 100 items. The next session is case study. I will talk about an example of a renewal project of the sticker recommendation logic of the Smart Channel that was launched about half a year ago using this Libra suite. The project involved significantly renovating the logic of machine learning from the on the back end, from the old collaborative filtering to an end-to-end deep learning model. The scope of influence and impact was so large that we needed to work closely with the service side and carefully plan the project. We conducted 5 A/B tests until this logic was finally released. And in addition to Japan, separate A/B tests were carried out for Thailand and Taiwan. In the first A/B test, we changed the machine learning logic from the existing collaborative filtering to the new deep learning-based logic. So we ran an A/B test comparing the two. In addition to the sticker image, we added users' purchase history and sticker transmission history as features to the deep learning model and got positive results that both impressions and target users were increased. The second test was an A/B test that changed the deep learning model to end-to-end. By training based on the user's log data every day, we were able to quickly incorporate user features and achieved a large number of impressions. In the next test, the result of the second test was good, so in order to expand target users, we made adjustment to expand the features of the user's sticker purchase history and conducted A/B test in Japan region. As a result, we grew the number of impressions by 5 times. Then, in response to this positive result, in order to further expand the users, and also in anticipation of expanding this to Thailand and Taiwan, we adjusted the filtering conditions of target users and conducted another A/B test in Japan region. As a result, the number of impressions grew further as we expected, but the quality of content recommended to users and the quality of stickers and the response from users did not go down so much. After that, the logic tested in Japan region was adjusted for Thailand and Taiwan regions, and A/B tests were conducted. In these 5 A/B tests, each setup takes 1 hour. The test period is about 2 weeks. 2 to 3 business days for the confirmation of implementation start and completion, coordination for the release, and others. We seamlessly conducted 5 A/B tests in the course of 3 months and finally released the logic successfully. However, this 3 months of testing wasn't a smooth journey. Machine learning logic mistakes and configuration errors integrating to the service-side system occurred about 3 times along the way. But all those were detected by the Libra report, so it didn't affect the release. The first mistake was that when applying the end-to-end deep learning model, the behavior changes due to Spark's reliance on version, the implemented code could not be filtered well in the A/B test production environment, and the same sticker was recommended to the same user multiple times. During the A/B test, I noticed the error from the Libra report log and tester verification with actual machine, so I stopped the test and revised it and tried again. The second one was that there was a configuration error to deliver test stickers that is integrated with the service-side system. So the sticker data of the comparison group was not delivered correctly. I noticed this in the real-time metrics of the Libra report 1 hour after the test was started and immediately stopped the test. The third one occurred in the phase of reporting using Libra report after conducting tests to expand users in Japan region. And since we calculate the impact on other services such as ad advertisement in addition to stickers, we noticed that the number of impressions of the ad advertisement dropped more than we expected. Based on the report, we quickly discussed with the service side, and they gave us approval on the release itself with the condition that we will implement another measure to increase ad advertisement impressions. After going through these A/B tests and finally releasing the logic, as a result, as you can see, the sales of stickers increased by 900,000 yen daily, the number of impressions increased by about 50 million daily, and in Japan, the number of target users has increased to about 2.5 times. As for the future work of Libra Suite, since its release, many users have requested repairs and improvements, and I would like to introduce some of them that I would like to prioritize in the future. Regarding Libra itself, I want to add support for service side to freely conduct creative A/B tests, and also to support for A/B tests based on item-to-item recommendations. With Libra report, we want to support more line services. And at present, it can only output metrics aggregated by a certain query, but we want to allow users to commit customized query via Git by implementing workflow engine like Airflow. As for Libra Checker, we want to add support for demonstrating the comparison with the historical machine learning output and for cross-domain recommendation demonstration. Those are the type of work we're planning for the future. Finally, the linedevday Labs machine learning team has currently three open positions: machine learning engineer, server-side engineer, and ML ops engineer. Details can be found on each link, so we sincerely look forward to your application. That concludes my presentation. Thank you very much for your attention.